Hello, we are going to talk about example 36, and it says that consider x is a random variable, x is a random normal distribution with mean mu and our variance for. Find the value of mu given that the probability of a random variable x is less than or equal to 2 is equal to 0.556. So what happens in this one is that we're going to try to find our mu, and we can use we know that if we wanted to find a standard normal distribution, then this standard normal distribution with we would have x minus mu over our variance, right? And since we know that the probability that our random variable x is less than or equal to 2, that would equal to be 0.556, then we know that we can normalize this area here. If we take the normal area, then we can normalize this score. So using this values up here, this would be our random variable 2. So we'd have 2 minus our mean over we do know our standard deviation in this score. This is our variance. If this is variance, then our standard deviation is actually 2. And then if I take the area of this for a normal distribution, because these are the values that normalize it, so I would take the inverse of this value, which is 0.556, then I can figure out what this value is. I'll just go ahead and solve this, right? So I'll multiply by 2 to both sides times the mean, and I'll have 2 times the inverse of the standard normal, the normal inverse right here, and then I can add m, but write it left to right. I'll end up with 2 minus 2 inverse of 0.556. Now I can use the calculator to figure out what my mean is, and I pretty much have it already up here for you guys. So it's 2 minus the inverse normal right here, and that comes out to our mean is equal to 1.7183 approximately, and there you go. So we can use the standardize the normal distribution to solve problems like this when we don't know our mean. And now the next problem we're going to look at has this one we didn't know our mean, but now we're not going to know both. So to look at this example right up here, 37 says that we know that x follows a normal distribution with mean and variance. As such, find the values of the mean and the standard deviation given we know that the probability that x is less than or equal to 2 is equal to 0.546, and that the probability that some random variable x is less than or equal to 3 is 0.743. So for the first one, let's start with the first one. So the probability that our random variable x is less than or equal to 2 is equal to 0.546. We'll do the same thing. We know that our z is going to be our random variable x minus our mean over our standard deviation, but we don't know both. So I know that here is my random variable x. 2 minus mean over standard deviation is equal to the inverse of a normal, and that has to be, since we normalized it, it's 0.546. Good. And now what I like to do in the calculator here is I'll figure out what that score is. So I'll go menu 65 inverse normal 0.546, and then I'll know that that is what it's equal to. But I'll store this as some variable. I'll let it be a. So I'll store that as a. Good. And now I know what a is, and then I can solve an equation for this, right? Multiply by my standard deviation. So I got 2 minus mu is equal to a times my standard deviation, right? And then add m. So I actually have an equation with 2. A is a constant. I know what it is. It's just loaded up into there. But I have a equation with 2 unknowns, basically. One equation with 2 unknowns. If I add m, then it's a times the standard deviation. And then I can do the same thing for the other parameter here I have. So I know that the probability that x is less than or equal to 3 is equal to 0.743. Then I can normalize this distribution. This time my random variable is 3 minus mu over my standard deviation, and then I'll find my inverse of that normal, right? I've normalized it. The inverse of the normal has to come out to this. so it's 0.743. Good. And then I'll do the same thing that I did before. I'll find out what this value is right here. Sorry, I'm off the screen a little bit there. And then I can just go ahead and use this guy right up here. And I can put that number 743. And now I know what that value is. And I'll just store this as B, something different. So store as B. Good. So now I can solve this equation. And I'll have 3 minus the mu equals, it's going to be B times my standard deviation. And then 3 is equal to mu plus B times standard deviation. Good. Now I have remember now, A and B are numbers that I've stored in my calculator. So they are constants, but my two unknowns are my mean and my standard deviation. And I can use my algebra systems of equations to solve this, right? And I'll even change these to my, let's make this M for my mean, and let's make this D for my standard deviation, right? So I have it like this. Then I got to plug these two calculators. I got 2 equals M plus A should have been stored. It's highlighted, so that's good, times my D, which is my standard deviation. That's my first equation. And then I'm going to have 3 equals at my mean plus, I've stored B, it should be highlighted, that's good, times my standard deviation, which I called D, right? And then I can solve this equation right here. And this is MD, so my mean comes out to be 1.7848 approximately, and my standard deviation is 1.8619. And there you go. So I used a calculator to solve all this up. I normalized it, and I was able to solve equations. I had a system equation. You could have done it by hand in other ways, but here's the way I do it with this, and it gets done pretty quick. Thanks, guys. Sounds good.